Start. Okay, so we're going to implement a long list task tracking system using the simple scanning algorithm from Mark Forster. I'm going to be implementing this in C# using Visual Studio 2019 preview. This is the brand new one, so it's preview 16.0.0 preview 4.1 SVC1. So with any luck, we won't have any major crashing issues. Fingers crossed. The first thing I want to do here is to create a place where I can build my application. I don't like working in Program because Program requires me to work in static namespaces for most of my time, or to instantiate an actual instance of Program, which is kind of a weird thing to do. So the first thing I'm going to do is create a new class called something like app. We'll just call it app. App's a good thing. We'll just call it app. We could call it application if we prefer. An app is going to have one primary functionality. That functionality is the ability to run. That'll be the only public class or only public method that will be available outside of this class. So we'll call that run. Well, we have to turn off IntelliSense because IntelliSense is the worst. And it will do some stuff, but not yet. We don't want that to return anything, it'll just be void. And that's that all set up. Now in Program, in our main, there's only one thing that we actually want to do, that is to instantiate this app and call the run method. So we'll say new app.run. You'll note that we don't have to store this application, this app, in a variable of any type in order to call this first method, or this really only method that we'll be calling on this. We can just instantiate it here as an anonymous object, an object that doesn't have a variable name associated with it, and it works perfectly fine. So this is the only thing that's going to be in our main. And so I'm just going to close program.cs and never come back. So I guess it's good to note at this point that I'm not really going to be building an object-oriented application this time. We haven't talked too much about object orientation. So I'm mostly going to build this as a fairly simple imperative type of application, like you would see if you were building in C or in a script style Python type of situation. So this will be fairly simplistic, not necessarily the way that I would do it in real life if I were to actually sit down and write this, but it'll be faster. We're using the agile methodologies here, move fast and break things. So at my top level, I want to go ahead and describe the things I want the application to do. And scrolling down my list of requirements here, let's see, that's F12. There we go. Scrolling down my list of requirements here, I think the first thing that needs to be implemented is this ability to save to and read from files. This is the first thing I want my application to do. It's not necessarily the first thing that I want to implement in my application, but it's definitely the first thing that I want to say my application will do. So we'll start with that. The first thing we'll just say is read list from file. And we need a place to put that. That'll be some new list type. So we'll just say that tasks for the moment are strings, and we'll call this task list. And the only thing that we'll do here is read from file. So this doesn't exist currently. We can use control dot, and we can generate this method automatically for us. So in order to read something from a file, you probably want something like a stream reader. We'll go ahead and say using call allows us to create a context in which we can use something that is idisposable, so something that can be created and disposed of, like a file handle. So we're going to use a stream reader here. Well, stream reader doesn't appear to exist. Probably we need system.io. You know what, let me try this and see something. Stream reader SR. See if it'll find that for me. Beautiful. So it does actually find that for me using system.io. And again, that's that control dot key. And we can go ahead and say that this is a new stream reader, and it expects either a stream or a path or a variety of other things. We'll go ahead and use the path option since that's exactly what we're looking for. So I have to make up a path. I'm just going to open up Explorer. We'll go to local disk, users, my username, and we'll stick it in documents actually. Go back. Documents, there we go. You do have to go to that path explicitly or it's a little difficult to get it to give you the full path. At least I think it is. Might be wrong. Yep, it doesn't give you the full path if you don't go to it explicitly. So we can paste that here. That's going to be our path, and then we need a file name because the path is not sufficient on its own. And we'll just call it tasklist.txt. Sure, txt will work. It won't work for the long term because it's not going to end up being a text file, but it will work in the short term. So we're going to need an interim place to store our list. We weren't passed in a list, so we have to create one on our own. We'll go ahead and create that and just call it task list as well because there's no reason not to. Var new list of strings. We'll use lowercase string here just for the sake of consistency. So in here we want to add something to this list every iteration. So tasklist.add, or yeah, well, that needs to be lowercase. Fix yourself. So stop. But we don't know what yet. Just something. That something is going to be something that we read in from the file. So we can use sr, the stream reader, .read line, and we should be able to read in a line of this file one at a time, just like we would do with something like console.readline. We can store that in a var, or we could read it directly in. I'm going to go ahead and store it somewhere because I might need to do some manipulation of this at a later point in time. So let's say this is going to be called var input equals sr.readline, and for each of those we're going to add it to the task list. Simple enough. At the end of the course we need to return something, undo, so we can return task list. Serves me right for choosing something that starts with the word task. It's going to constantly recommend that I use the capitalized T task the whole time I'm doing this. It'll be fun. So I already know that this is going to break horribly because we don't necessarily always have that file. The task list file doesn't necessarily exist. Like right now, it doesn't exist. And so this is going to throw me a file not found exception. I don't care about that. I don't care about that file not being found. I just want it to do the right thing. So I'm going to do something a little gross. I'm going to just wrap this whole thing in a try block. Do I want to do that, or do I want to do something else? Let's think. I mean, the appropriate way to handle this is to actually check and see if the file exists, and then if it does, to do this. I'm gonna do it anyway. So we're going to catch a file not found exception, and we're just going to throw it away. Stop. Thank you. So this is a block that does nothing. This is probably a little hacky. I'm not super pleased with it, but it'll work for the moment. And so now we can run this. And it doesn't work. Why doesn't it work? Oh, right. So there are multiple different ways of interpreting strings. If you have these backslashes, normally it's going to interpret these as escape characters. And they aren't escape characters, they're just backslashes. I could go in here and do double backslashes to escape the backslashes, but I'll just go ahead and use the @ double quotes type of string to let it do that for me. With any luck, this should run, and it does nothing because that file doesn't currently exist and because we don't do anything with it. So the first thing I want to do once I read in data is, I don't know, print that data to the screen. So we're going to print data, or print list, print task list. I like that. We'll print task list. And we'll pass it a task list to print. Task list. And, you know, it'll be the best place to start for the moment. So we want to be able to print this. Pretty easy to print a task list out, at least if you're only printing the whole thing and not printing just the first 25 items. We'll go ahead and say for each var t and task list, which is capitalized again. I did that one that time. CW tab t. Should be simple enough. And we could go and we could manually create that file and we could see that it was working. We're not going to. Just going to run it, make sure it runs, move on with our lives. So at this point, I need to add this to version control, because if I don't, I'm going to end up messing something up and regretting it. So this is now in version control. It's all been added. I'll be popping back and forth to this moving forward. Okay, so we can print a task list. Let's go back to our list of requirements here. That means that we can now save to a file. We've done that. Simple scanning is less of a requirement, I think, and more of a top-level view. We have said more about that further down the list, so I'm happy with that being in the, if you will, the things that are done list. Let's see, we have built this in the console already, so we can move that up. We have the ability to print items, but not necessarily 25. Let's go ahead and say that inputting tasks is our next thing we want to be able to do, because that will move directly into our ability to choose a task or to provide these other controls that are provided or that are listed down here at the bottom. The select a task, action a task, etc. So we're just going to create a situation where we loop printing task list and then asking for a new task. And that'll give us a good starting point. So we'll say do, because this is something we want to do at least once. That was a little extreme. And we want to do this until we are asked to quit by the user, whatever that means. So while not quit, we'll make quit a bool. Var quit equals false, because we don't want to quit the first time through. We're going to put this, well, you know what, we'll just go ahead and do it now, rather than talking about it. We'll say input new task. That'll be our new task. And when we input a new task, we'll add that to the task list. Now we could have it manually manipulate the task list. I'm not sure I want to do that. Maybe we will. We'll say input task list and we'll pass it a task list to which to add a new task. I'm okay with that. Okay. We'll need to create that. And when we input task list, we will say console.write. Note this isn't write line. Call it add a new task. And then we will read line. So we're going to store that somewhere. Our input equals console.readline. And then we will put that into the task list. Oh, sorry about that. I messed up. Oh no. Oh, it did pick it up. Cool. That's my fault. So we'll go back over that. We went ahead and we created a do while loop that we're going to put around our ability to print out a task list and input a task to that task list. When we input a task to the task list, we're going to pass the task list into the new method. And that's going to allow us to update that task list automatically inside of the list of or inside of the input method itself. That's due to passing by reference, which we'll talk about soon. Okay, so we'll just go ahead and add input. Again, I didn't necessarily have to put this string input that we're getting from the command line into this new variable, but it's possible at some point that I might want to do some sort of manipulation or other checking of this variable, and I'll need to actually care about that at that time. Ooh. Okay, that's all good. Checking bitrate seemed a bit lower than it ought to be, but it seems to be okay. So let's try this, see what happens. So this gives us a list and says add a new task. We can add in, we'll just use some dummy variables here, if you will. Okay, so we now have the ability to add things to our list. All well and good. No ability to quit yet, but we'll come back to that. So that's one possible thing that we might want to do. It's not the only thing, however. It's possible that we're going to want to select a task off this list. You know what? Before we do that, let's work on writing these tasks out. I think it's important to be able to read from the console and then write out to a file so that we don't have to continually be adding and removing these tasks. It's going to waste me a lot of time if I have to add a new set of tasks in to test every time. So let's make that write happen. So in order to write, we need a new method, of course, called write list to file or something equivalent. We need to pass it a list by task list. This, of course, doesn't exist. So we're going to generate it. I'm actually going to move this down here to live with read file from list. Make sure my spacing is right. Yep, we've got a parenthesis there, all good. So we're going to use something very similar when we write to list that we did when we read from the list, and that's going to be the stream writer. The stream writer also takes a path, and it takes a couple of other parameters that we'll look at. So we're going to say using stream writer, we'll call it SW equals new stream writer. And we'll put it in that same file. Oh, you can ask questions, that's fine. I'm going to be a little bit latent. This isn't my normal setup. Here, give me a sec. Which button is which here? Nope, that's the one. There we go. Yeah, this isn't my normal setup. Normally I do all of my coding in the middle window, and then I have my questions and whatnot on the far right. Today I'm working in my Visual Studio virtual machine, which usually works better in the horizontal monitor. I've got two vertical monitors and a horizontal monitor on the far left, and so I'm not really looking at the appropriate screen for this all to happen. But please feel free. I can ask as soon as I notice, at the very least. It's not necessarily bad practice. Oh dear. What did I do? Oh well, we'll bring it back. It's not necessarily bad practice, and I may end up making it a class level variable at some point. If I end up passing it to every method that I'm using and modifying it in every method that I'm using, I'll probably just make it a class level variable. It's not my immediate go-to, mostly because of my functional programming experience where you kind of pass everything back and forth. Okay, so this should be pretty simple. We're just going to be printing something out to the console. So it's not really or not to the console, sorry, but to a file. It uses the same interface as you would if you were printing out to a console. So we can just print out each item in this list using the same kind of method that we use in print task list. In fact, we can just copy this, which isn't normally good practice, but I'm doing it anyway. Control KD. Oh dear. Control KD doesn't work the way that it used to. Oh, very dear. Oh well, we don't have closing parentheses here. Oh dear. That's a curly bracket, incidentally. What have I done wrong? Oh, I didn't close. It is the parenthesis. That's much better. Okay, and now instead of writing to the console, we're going to write to the stream writer, if you will, the SW. So let me go back up here. We're going to add a little bit of spacing so that this is a little prettier than it was. After this whole thing, we'll just console.writeLine, which I can just do CW tab tab, much better. Does that answer your question? And we'll run this. So we want to add a new task. You know what, let me just pull up my book here and we'll add a few real tasks. Beautiful, thanks. We'll add a few real tasks. Wow, there are a lot of games in this list. Wish I had more time to do them. So I've got a bookshelf I need to build. I'm just going to call that bookshelf. And every day I do super memo. So we'll call it super memo. And let's see, I've got my passenger rear window on the car is broken. So we've got passenger rear window. I want to play some Zelda later. I wouldn't say it's necessarily a bad habit. It's just more a situationally correct or incorrect thing. That's probably the best way I have to describe it off the top of my head. And again, I'll probably end up switching to that particular methodology as we move forward, but that's okay. So I need to clean my shower. Shower needs cleaning. I need to do some grading for homework specifically, and I need to do the 2-hour task manager, which is of course what we're doing now. Sure. So this is a list of real things. Oh, shoot. So we have a problem. I haven't actually created a way to quit the loop yet. So there's that. I'm just going to copy this if it will let me. Copying things from this is not trivial. Ah, beautiful. It did work. So we'll just force quit here. Good enough. Incidentally, you cannot really easily catch the console window closing using the X button if the user presses the X on the console window. Really hard to catch that. It is doable. You have to link into the System32 DLL so that you can work with the actual underlying code to do that. I really don't want to. It's a little icky. If it were a production application, I'd do it in a heartbeat without hesitation. But for a demonstration like this, not into it. So I guess the first thing to do is run an input loop, I guess, rather than inputting this task to list. Inputting task to list is something we want to do eventually, but it's not something I want to do right now. And so actually this is the point where I'm going to go ahead and move this to class scope, because that's going to keep me from having to pass it down 2 levels. So this is of course private by default, as are all of these. I will go ahead and notate it private though, just to be explicit that it's private. And the very first thing we'll do here is tasklist.readList from file. And in fact, we don't even need to do it there. We could do it in the constructor. So let's go ahead and put it in the constructor. We'll build a constructor up. That needs to be public app. And that will be the only line in the constructor. That's an appropriate place to put that, incidentally. It should be in the constructor and not in the app itself. There is a line of thinking that says that you should put the right list to file in a destructor, and I'm not against that, but I'm not going to. If this were C++, then I would definitely do it there, because that is the appropriate place for that. So let's just go ahead and remove these, and we're going to remove these as method calls, or as not as method calls, but as parameters even. Beautiful. And now we should be able to do everything, well, there too. We should be able to do everything we want to do without any errors. Beautiful. let's go ahead and add this to a new commit. It's going to be, if applied, this commit will move task list to class scope. Go. Thank you. We'll just always ignore that. I know where I can push my things if I need to. So we're going to remove this from inside the loop. This is going to be our, This is going to be our, let's say run input event. Run event loop, naming things is hard. Run input loop. Run input cycle. How about that? I like run input cycle. We can create that method. Again, that's c dot and enter, which just chooses the first option, which is almost always to just create a new method. Okay, so in our run input cycle, we want to have a do loop. In our do loop, we want to get input from user. But before we get input from the user, we want to print usage options, I guess. And then while not valid, we want to do the loop. So what is our input going to be? Our input's going to be, There are a couple of options we could do here. I'm going to go ahead and say that our input should be the return value of running console.readline, or read key, excuse me, read key. That's going to give us just single key press options for our menu, which is fine. So console.read key. I don't recall what the input or the return type of this is. It is a console key info. Okay, so console key info equals that, but there's something we can get from this. Let's see, just run down this list a little bit. This gives us a console key, which is the actual representation as opposed to this object that's kind of wrapping a console key. We could also get the Unicode type, which is a little less useful. If we go with the Unicode type, that doesn't allow us to grab things like arrow keys, which I may want. We don't really need modifiers, excuse me, because I don't care particularly if somebody hits Alt and a key. If they do that, then they ought not to be in my application, though I really probably should be less carefree about that. I'm going to go with console key for this. So we're going to say this is going to return a console key. And console key, and at the end we'll return console key. Okay, that's going to throw errors all over the place because we don't ever initialize it, which is fine. Can't spell false. I don't need that to be a bool, it can be a var. And we'll say key equals that. So I think that will work. Okay, let's start with print usage options. In print usage options, we're just going to print out to the console the various things that a user can do. So we'll say console.writeLine, and let's see, A to add. A to add a task. Down arrow to proceed. We could actually go and find an arrow here, but we're not going to. To proceed through the list. And I don't know what's the last thing we should be able to do. I guess next page. Well, I guess we could go to our list of potential tasks here. We need to be able to select a task, and I'm going to have them do that using the up and down arrow keys and the enter button. They can go to the next page, so I guess I need a in, if you will, to go to the next page, or maybe I could do right arrow key. Yeah, I'll do right arrow. Well, I might use right arrow to select, so I'll do in, the in button for the next page. We need to be able to add tasks. We've got that with A, and we need to be able to delete a task, which we would like to be able to do with one step rather than doing it with multiple steps, actioning a task and saying cancel. Or excuse me, actioning a task and then saying complete that task. So we'll add one key, the D key. So we need the N and the D key. Okay. Down arrow to proceed through the list. In to go to next page. And let's say enter to select a task. These are all out of order. And D to delete. So this is way too much text. The number one rule of user interfaces is minimize the quantity of text, that you have. So we're going to break this down. Add. In next page. D delete. Enter select. Action. We'll call it action. And what's our last one? In D enter right. Down arrow. Down arrow to select. So you'll note at this point that I don't have an up arrow, and that's mostly intentional. The general idea behind these long list methods is that you never want to go up the list, at least not at this stage. There are mechanisms that allow us to do that, but with simple scanning, you can only go one direction through the pages. So I'm only going to allow the user to go forward on the list for now. May change that later. Right now we can just select down to here, and we're set. And then we can ask for input. Just like that. Oh yes, and we need a way to quit. I forgot a way to quit. Q to quit. Easy enough. We could even probably make these a little easier to read. Select this way. I'm not going to spend too much time making this pretty because it's not a hugely important part of the process. But I'll do at least a little bit. I do wish that I could have a single down arrow. Oh, what's the ASCII code? Arrow symbol. It is Alt 24, Alt 25. Can I just copy you? I can copy you. I'm working in a browser in a different window at the moment. That is Unicode 21903. With any luck, this will work. -U21903. Hey. Okay. The enter symbol actually has its own Unicode as well. Let's see, that is 23 Charlie Echo. -U23 Charlie Echo. Well, that didn't work at all, did it? Beautiful. And Q to quit. I like it. With any luck, it'll work. Let's try. There were build errors, so it didn't work. Well, that's because I don't have get input from user yet. We'll just go ahead and say that. The throw not implemented exception gets rid of the need for the... Well, that's interesting. Odd. Well, it gets rid of the need for the return. So this should work. Oh dear, my console doesn't like those characters. That's okay. Ah, yes, that would do it. Thank you. Good call. We'll go ahead and put that in the constructor. There we go. See if that works out. Well, that got the down arrow. It didn't get the enter key. Let me make sure that I got the right Unicode for that. 23CE. That's way up there in Unicode. But it should be doable. Well, there may be another one. That's 23 Charlie Echo. That's the return symbol. Why doesn't the return symbol work? You'd think that one would be one of the most basic. Maybe 21 Bravo 5. And if not, I'll just say enter there. Yeah, it could be my console font. I think I'm running Consolis though, which is the default. Yeah, I am, which is the default Windows console font. It's good enough. We've got down arrow. I'll take it. It's not worth spending lots of time on. Yeah, that's actually a good point. I could char map. Yeah, but I'd have to find it. Either way, I'd have to find it. Let's see if it's on here. Give me the advanced view. Search for 21 Bravo 5. Well, that didn't work. Solos. It's way down the list. Actually, we'll search for the return. Well, that didn't help me. Yes, Unicode. Enter. Nope, not there either. And one last thing we'll try. Go ahead and copy this guy. And see if I can paste it there. Ooh. Well, that was interesting. Definitely didn't give me what I wanted, though. Let's see if we can just paste it here. Ooh, that works. That's kind of neat. Yep, still doesn't show up, though. I'm just guessing that Consolis doesn't have that particular key, which is fine. I don't really need it. Though I'd like to have it. Okay, back to what we were doing. So we don't currently call input task to lists. I'm just noting that it's kind of grayed out here. That's okay. We'll call it later on when we get the input from user, or potentially when we handle the input from user. Let's see, handle user input key. Yeah, I think I like that. That needs to be capital H. And then we will control dot there and run that. Get input from user is going to be fairly simple. It's just going to, for the moment, return console.read key. And we do need to say dot key. Okay, so now we can select on the keys that we want, or switch even, switch key, and we have a couple of cases. Oh, good grief. IntelliSense, stop your such and so. Okay, so case console.a, nope, console key.a, there we go. This is the A key, unsurprisingly. We're going to handle that. Tab that in, and then we're just going to copy and paste this line a bunch of times. One for each of our viable inputs. So that's A, D, N, the down arrow, the enter key, and the Q button. All these will need to be tabinated. I need to put a curly bracket there. Thank you. So we have A, we have D. Is there a lowercase d? There is not a lowercase d. We have the in button. We have the down arrow, which is just called down arrow. We have the enter key, which is either enter or return. I don't remember. Okay, it is enter. Good. It's also possible that it treats the enter on the number pad differently from the enter in the return button, if you will, the one below the backslash. Not certain about that. I would hope not, but it's not unlikely. Okay, so in each of these cases we want to do a different thing. I do want to say that we don't necessarily want to do everything that we said we wanted to do. For one thing, let's see. How best to handle this? Well, we could do 2 steps worth of checking. What I'm trying to do here is figure out how I'm going to handle both the management of the quit button as well as the management of the let's see, management of the quit button as well as the management of input validity. So you know what? I'm just going to say that if you input an invalid character, then I'm going to redraw the screen, and I'm not going to care. I like that. So I'm going to do this. I'm going to delete that. Tabinate these. And that's that. So that'll be run input cycle, and then we'll call handle user input using the key that is returned from run input cycle. So handle user input key. And we're going to go ahead and say that quit equals whatever the result of that is. So this now needs to return a Boolean. And the only case where we're actually going to return true from this is in the Q case. So we'll say return true here. And other than that, we will just return false. And the default case will do nothing. I'm going to go ahead and remove this unreachable code. In general, you wouldn't want to delete the break there, but it says we don't need it, so I will believe it. Okay, so in the A case, we want to add a task. So input task to list. We already have a method for that. That's beautiful. In the D case, we haven't handled that one yet. Same with the N case. Down arrow is going to change our selection, which again is not yet handled. And enter is going to select a task, which is also not yet handled. So let's run this. Okay, we've got the ability to do all these different things. I can queue and it will quit. That's beautiful. I do want to, well, somewhere I'm going to need a console.read or a .write line so that this doesn't look horrible. I haven't yet decided where that should be. For now, let's not worry about it, and we'll come back to it. Let's try running this, and we'll add our list of tasks. Okay, so that does look terrible. But in the case of, go away. In the case of, well, you know what? Let's go see if that file was created. Ooh, that file was created. Good, it has nothing in it. In the case of add a new task, I want to clear the screen anyway. So we'll console.clear here. That's fine. In the case of quit, I'll just go ahead and put that console.write line here at the end. and I'll comment this so that nobody comments it out later. Ensures press any key to quit is on its own line. Okay, that should clear up most of our issues. Value assigned to quit is never used. Okay, that's fair. Cool, much better. Name could be simplified, just going through and cleaning up a little bit. And we'll go ahead and do that there too. Okay, I think that has us in good shape for the moment. And we can commit here. So if applied, this commit will create the basic input usage loop, our input handling loop. Yep, I think that works. Okay, so far so good. Let's switch back to our, oh, go away. Switch back to our list of tasks here and see what we can do. So we can now input tasks. I do need to test that. So I'm going to put it in its own little verify category here in the middle. We can't choose a task using the appropriate algorithm. We can't re-enter or cross off. We can't list 25 items at a time. We can't cross out actioned items in dark gray. Let's see, the first page starts with the first unactioned task. I guess that's by necessity since we can't action a task. We can add tasks. That's done. So I'll just add some, well, I'm just going to delete it, I'll be honest. And that's that. Okay, so let's test to make sure that inputting tasks works properly. I run this, hit A. First new task is to work on the bookshelf. Next task is to work on super memo. Third task is to work on the passenger rear window in the car. Third task is to play Zelda. Okay, that didn't work. That's good. Next task is to shower. Or work on the shower, even clean the shower. The next one is homeworks, need grading, and the last is the 2-hour task manager. Okay, so now we have this nice list of tasks. Just looking at this, I do note that I want to have a console clear right here before we start printing out our list of things. So that's something I will need to add, particularly since if we put in garbage keys, oh dear. Well, I have no handling. Here's another bug. Okay, so I have no handling for a blank task added. So I'm going to have a blank task at the end here. That's not good. So I need to do both of those things. So we're going to quit here. That does look appropriate. And I'm going to add a console.clear to the print task list. Well, that didn't work because I've now got F12 bound to something on my operating system as well as an OBS. So that's unfortunate. I can change that later. So print task list, there we go. We're going to say console.writeLine here. And then in input task list, this is where the fact that I have an input here is happening or is valuable. If input dot, there should be a null or empty. Maybe it's empty or null. Well, we'll do it this way. If input equals double, or does not equal, I should say, an empty string, then go ahead and add it to the task list. And we don't use that not equals operator in C#. There we go. Okay, so those are my 2 bugs that I just found. Now let's go and modify this file so that this empty line is inside of it because it should never have been allowed to be inside. Beautiful. Thank you. Save me a nice lookup in the MSDN, or what currently passes for MSDN. So that's string.is null or white space. Yeah, I guess I'll take null or white space. Yeah, exactly. Pair programming at the very least. Is null or is or consists. Okay, I like null or white space better. Input, cool. Thank you. And that ignores that. If not, there we go. That almost got bad. Okay, so that fixes all those problems. What's the next thing we want to do? Oh, well, I guess we should run it. Ah, now we have a problem. So this should have read in from the file, but it appears not to have. So let me first go and check this file. I'm going to open it in Notepad++ because Notepad++, they're all gone, goodbye. Notepad++ allows us to show all characters. We've got an empty CRLF here. That's a little weird. No, go away. So the empty CRLF is not necessarily bad. We may have to do some checking for it. Let's go ahead and run it, just adding one task. So we'll add in, I don't know, Zelda. And then we'll actually check and make sure that, okay, so adding white space now does the appropriate thing. Quit. Didn't I put a clear line in there? That's weird. Let's go back and put a clear into print task list. Print task list. Console.clear. Better. Okay, so now we do have that in here. We're printing a CRLF before, which is a little odd. I'm curious why that's the case. It's possible, it's possible that it just read it out of the file last time, which is, of course, not optimal. Yeah, so what we're going to do, every file should really end with a new line, and that should be handled appropriately. We'll see if that's actually the case. Okay, so we do have one thing in the list now, and if we quit, we should see... Okay, the file does look exactly the same, so it must have just loaded that CRLF from before, that empty input, which was bad. So this file does look the way that I would expect it to, and I'm just going to go ahead and copy all this stuff in so I don't have to do it again. Copy. Paste. And we'll need a new line there too. Again, text files should always have a new line at the end. That's definitely a Unix thing. It may or may not be a Windows-specific thing. I don't actually recall. Did I not save? I did save. That's interesting. So we have a bug, and that bug is that I didn't do this right. So what we want to do here instead is say while sr.end of stream not. So while we're not at the end of the input stream, the reading stream, we want to get input one line at a time and then add that input to the task list. Ah, beautiful. So now we have a list of things. That's exactly what I expected to see. Okay, so the next thing I want to do is determine whether or not something is, words I'm looking for here, whether or not something is currently actioned. So I could keep a tuple, or I could build a new struct. There are a variety of different ways that I could handle making this happen. I'm going to do it in a more traditional imperative C-like way, just by having a second list of items. So I'm just going to have a list of booleans, effectively. And we'll call that the isActioned. We're going to change task list. I'm going to call these tasks from now on. Tasks. I think that's a little more clear what I'm trying to do. So we have tasks and we have is actioned. And at the moment we have no way of saving whether or not a task has been actioned. So I'm just going to say that all tasks are actioned. It's down here where we load stuff in, or excuse me, all tasks are not actioned. So it's going to be false. Down here where we add stuff in, we will input a task line. We'll add, oh dear. Actually that's fine because we declare an internal bit here. We don't have to do that anymore, though. The penalties of starting off doing things one way and then moving to a different way. So this is going to be tasks. And then we'll add is actioned here. And we'll add false. That's not the final status of that, but we'll come back and fix it another time. Okay, we can do that now. And I think that will work. Okay, read list from file, doesn't need to return anything anymore. It's just setting up the class. Okay, there's that. And I do want to note at this point that if we wanted to go back later and make this into a more object-oriented, appropriately formatted, solid, compatible, choose your words type of thing, we could do that. It wouldn't be too hard at this point to break this out into a user interface and the actual domain logic that is working with the list and with whether those items in the list have been actioned or not. It's a fairly simple step to move there, but we're not going to. It is left as an exercise for the reader, if you will. Okay, so next things to do. I want to be able to, well, in order to action something, I have to be able to select it, and I'm not quite there yet. But I do want to be able to read and write whether something has been actioned or not. It will make everything unactioned when I load the list, and that's okay, because at the moment I don't have a way to specify that something should be actioned. And so everything that's currently on the list should be unactioned by default. At the very least, so that when I write out the file for the first time, everything will be roughly what I expect. So I'm going to use the code effectively to initialize that file. So let me just go ahead and do that. Okay, so rather than using this for each loop, because I'd have to do some sort of weird zip and then put everything into a tuple, which is something I'm very comfortable with coming from the Haskell world, but something that is probably not as intuitive as it ought to be to most people. I'm just going to use a for loop to make the output writer work. So for int I equals 0, I is less than tasks.length, or .count, excuse me, and plus plus I. And so now rather than doing this, we will say t at I. Or tasks at I, excuse me. I haven't really decided how best to serialize a Boolean, so I'm just going to use its isString instance. It works well enough, and it will allow me to use bool.parse when I read this back in. So let's do that. We'll just use the string interpolation syntax here. I don't actually want to use the comma or anything like that because somebody might use a comma in their task. So I'm going to use the \hexadecimal 1e character, which should be the ASCII record separator. Let's see, do I have an ASCII chart here? Yes, I do. So I can just swap over to that. And if we look down here to hexadecimal 1e, yes, that is the record separator. Beautiful. So we'll use that. So this x means that it's going to be a hexadecimal character, and we'll use 1e there. That's going to show up in Notepad++ as a readable, usable character, and it won't show up anywhere else because it should be unprintable. We can try though. So the next thing we need is actioned at I, and an end quote. Okay, so with any luck this will work. let's go ahead and run this. We only get one try running it. Ooh, that was ugly. Apparently I didn't set is action to equal to anything. Oh. Well, there's that. And equals new list. So when I got rid of the setting here where I said tasks equals read list from file, and then I created that new list inside read lists from file, I was no longer initializing these lists. Well, I never actually initialized as action at all, but I wasn't initializing tasks either. And so we broke everything horribly. So with any luck, I should now be able to quit, and it will have rewritten my file in the format that I expect, and it does. It is in that format. Beautiful. What this means is that I'm now not going to be able to load in my file without having these weird characters. And we can try that. I'll just hit the X button so it doesn't save. You can see it does this question mark block where we have that hexadecimal 1E character, and we're not parsing out the Boolean here in the second field, which is fine. We can now go fix that. I'll go ahead and commit this first. This is going to be write actioned status to file. That's if applied, this will write action status to file. Ooh, actually, let me go back there real quick. Oh, that's cool. That's cool. So the new Visual Studio, and this may be in 2017 and I just haven't noticed it, but the new Visual Studio allows you to stash, and stashing is a really convenient Git capability. So I'm glad to see it's in the interface now. I don't recall seeing stashes last time I was in the 2017 Visual Studio, so this may be a compelling reason to upgrade to the beta, other than it just being a slightly nicer interface. Okay. So we can run this, and it will print out things that are ugly. We don't want that. So we're going to say var splits equals input.split, and we're going to give it a separator, and the separator is just going to be a list of, well, I think it has to be a list. Well, it could be a string instead. But then I have to give it options. I'll just make it a character array. That'll work. So new char box, and we'll give it just that one character \x1e. So then we can assert. I think there's an assert. There's not an assert. So what can we do? What can we do? We're going to go ahead and say if splits.count equals 2, which it should, then I guess I could have just put the closing curly bracket here and it would have been fine. Type group and int. What is splits? It's a string array. Why don't you work? Well, I'll come back to you. If it's not 2, then we don't have the 2 elements that we expect. Those 2 elements are the string input, which will be hopefully that first field, and the false Boolean that should, or true or false, I suppose. It'll be false to start. Boolean that should be in this second field. So we're going to say here that this should be splits 0, and this should be bool.parse splits 1. And if there aren't 2 fields on any line, we'll just ignore that line, because that line has clearly been corrupted in some way and is no longer valid for our internal code. Optimally speaking, we would print that out and we would say, hey, something went wrong with the input file, or we would try and recover that, or we would do some other thing that we can try, but for the sake of argument, or for the sake of brevity here, we'll just not do anything. Method group and end. Method group and end. Oh, that's a regular array. It's not a list. We have to use splits.length. My bad. So you can only use .count on IEnumerables, and arrays should be IEnumerables, but apparently they don't have the IEnumerable. Let's try that real fast. It's possible that they... Well, that's got most of the IEnumerable stuff. Extension count string. Oh, interesting. You have to call it as a method. That makes sense. That makes sense. Rather than as a property, because IEnumerable things are classes and they can have properties inside of them, and arrays are not classes, so they can't. However, they can have length, which is technically a property. So I'm really quite confused by that now. I wasn't, then now I am again. So when we print this out, we now only get the tasks, which is good. Let's X out of this to make sure we don't nuke our file. I want to come down to the end of this method here and just run the debugger and make sure that I'm getting the expected content. Now, of course, the appropriate way to do this would be to write a test class and to actually test this appropriately. Clearly, I'm not doing that, mostly because of the time constraint that was asked to be put on me for this particular exercise. Okay, so I am getting what I expect here. And in fact, I could do probably one more stage of testing and try and go in and say, for example, that I've already worked on Zelda and I've completed it. Oh dear. Which I, of course, haven't. It's a very long game. Well, okay, I've completed it once, but not twice. And we should now see true here. Well, I hit F5 instead of Control F5 because I have my controls reversed. We should see is actioned has a true in it now, which it does. Beautiful. So now in good shape, we can read and write. We'll go ahead and say that this is the, if apply this commit, we'll read action status from file. So we're one step closer to where we need to be. So now we want the ability to select a task or to select a item that is on our list. This may or may not be a task. It should be, because that's what this whole thing is about, but it may or may not be. I think the first place to start with that is the down arrow. Let's think. So the down arrow is going to allow us to modify a selector of some type. And that selector is not yet built. So let's start with that. We'll say that the selector is this thing. Oh, we haven't done color yet. You know what? Let's do color real fast. Because color will be a better first place to start. So when we print out our task list, we want to be able to print it out in color. And so we're going to change this to a for loop as well, so we can walk through each of our two lists at the same time. We're going to say for int I equals 0, I is less than tasks.count plus I. Pardon. We'll say here that we want to print out tasks at I, and if is actioned I, then we want to set the console foreground color equal to console color dot dark gray. And at the end, every time we want to go ahead and say console dot foreground color equals regular gray, which is the default console foreground color. It is important, well, it has to be AY. It is important to make sure that you reset the foreground color, not only so that your next task isn't weird, but also so that it doesn't print the entire empty section of the console with a different color than you expect, because the rest of the console is printed with the space character. And so you can end up with weird colors that you don't expect. So we see here that now Zelda has been marked in dark gray, which is our requirement. So moving back over here to the task list, we can now input tasks. We can cross out each actioned item using dark gray. And what else can we do? Well, that's about it so far. That's okay. Let's see. That. So next we're going to, well, we'll make a commit here. Gray with an A. Okay, so the next thing we want to do is have a concept of selected task. Ooh, sorry, just thought ahead a little bit and almost built an infinite loop. We're not going to do that. So let's start off with a concept of a selected task, and we'll just start that selected task at -1. So private selected task equals -1. And the main reason for that is so that we have a good default starting value that we can check for, is the short answer. Because we do want the user to have to give us some quantity of input before we start highlighting things, just to demonstrate that they are in fact highlighting the first item on the list. So we have to give this a type, obviously. And that allows us now to build a couple of things. So first things first, we can handle this in our print, well, where are we? Yes, in our print task list. We can handle this in print task list because we want our selected item to be a different color than our regular task. So we're going to go ahead and we're going to write the logic for this so that you cannot have a task be both actioned and selected at the same time. It's not technically viable yet, but we can assume for the future that that will be. So we'll say if, else if even, I equals is selected, or selected task, excuse me. Then we're going to set the foreground color equal to something different. Copy. Let's see, we'll set the background color. There may be a way to just do this. There is in many Unix terminals. You can just tell it to highlight something. So, well, I'm going to do it manually. It'll work out. We'll set the background color equal to gray and the foreground color equal to black. So effectively reversing the default colors. So it's still spelled with an A. And down here at the bottom, we now have to reset the background color as well. So background color equals console color.black. And of course, we can't have I equal to anything starting out because I is going to be -1, and -1 is not equal to any valid index of an array or a list. So that won't be a major issue. It'll just not select any tasks. Perfectly fine. I'll go ahead and make that commit. That's adding the basic machinery for selecting tasks. So now we need the ability to select our next task. And the time that we want to select the next task is when we hit the down button. So I'll go ahead and add that here. Select next unactioned task. And I'll create that method here. Now this is starting to get complicated. There's lots of stuff going on, lots of methods here. I would at some point want to clean these up so that they're in a slightly more readable order, have a little bit of white space between them, maybe even some comments. So I'm a little iffy on comments for individual methods. Lots of potential things that can be done here. We're just going to keep on trucking. So what to do? Let's start by saying that we want to increment the selected task, which is accurate. Now, if the selected task is and I'm not going to write this quite this way, if the selected task is a let's think. If the selected task is an actioned task, then we want to stop. And if the action or the selected task is an, nope, strike that, reverse it. If the selected task is an unactioned task, we want to stop. If the selected task is an actioned task, we want to continue. And then we have to be careful that we don't fall into some sort of an infinite loop where we have a list that has nothing but action tasks in it, which would be a little weird, but we'll think about it. And we keep going forever. So, let's start with the first case and ignore the infinite loop for the moment. Why did that close again? So weird. Must be one of the hotkeys that I have set up. Oh, yes. Yes, I have Alt F4 set, and Alt F4 is closing an application in Windows. Sigh. The difference between, or the issues that come with running a Windows VM on a Linux machine. Just weird stuff. So let's try this. We'll just do a do loop. Everybody loves a do loop. Yeah. And we're going to say while is actioned selected task. And we could add some logic in here to check for the infinite loop at a later time. Okay, let's try this. Okay, so that was argument out of range. That's beautiful. We were able to walk down through the entire list and select all the things except the one action task. Exactly what I was looking for. So now, of course, we need to do a nice little mod here. I've lost where I was. We need to do a nice little mod here that says, go away. Well, do we want to do a mod or do we want to just stop? Okay, let's do this. While selected task is less than is action.count and is actioned selected task. Is that right? Let's see. Not quite. So, we're gonna make a new bool. While not overflowed and is actioned. Bool overflowed. And that's going to start off equaling false. And we're going to say that if, well, I'm not going to do it this way. I don't like having both of these on one line. It's personal pet peeve. Selected task plus equals 1. If selected task is less than, or is equal to, greater than or equal to, sure, why not? Just in case. The is actioned dot count. Then selected task equals 0. We'll set it equal to -1, why not? And overflowed is going to be equal true. Ooh. And we could potentially do something with that overflowed value at a later time by returning it, but we're not going to yet. Okay. So this should allow us to go down through the list, and now presumably would return to the top, and we could continue down through the bottom. Okay, I'm okay with that. We'll quit here. I think I'm clearing too much. Getting a lot of flash from the console. That's okay though, I can handle it at another time. Okay, and you know what, we're just going to go ahead and return return overflowed. So that's going to allow us to write a nice little error message in the event that we do overflow. Well, it would normally, but we clear the screen every time that we print, so I'm not going to do that because it won't actually help us. I'd have to throw some sort of overflowed list exception to make that handled the way I want it to be, which is fine. I'm just not going to do it. So that allows us to select our next unactioned task. Let's say that we want to be able to delete a task. So delete currently selected task. The good thing is that now this is easy because we have a list of action tasks, we have a currently selected task, and we can just set the currently selected task equal to false. Super duper simple. That's going to be is actioned at selected task equals false, or excuse me, equals true. Super duper simple. So now we can, well, one more thing we have to do. Q. We have to walk down through our list and select the next unactioned task. I think. Now, is that the right thing to do? Well, arguably, if that's the correct thing to do, then it's also the correct thing to start at task 0, arguably. I'm not strongly against that, so I'm going to go ahead and change my -1s to 0s. Having your interfaces work consistently is very important. It's not nice to your user if your interfaces don't work consistently, and it is the hallmark of software that people hate to use. Gorgeous. Okay, so this works now exactly how I want it to work. Okay, and we can quit. You'll also note that our reading and writing code is working properly because I deleted super memo and it is now grayed out now that we've reloaded the application. Okay, so we don't have an idea of paging yet. That's okay. We can add and delete tasks. And now I suppose is the best time to action task. Action task. So I'm just going to make a new method here called work on selected task. And when I say we're going to do that, I mean that we're going to make a commit without that content there. This commit will allow us to, for me, yes. For the moment, yes. Yeah, deleting is going to be effectively the same thing as actioning in task and not re-entering it, so actioning and completing. Except in this case, it's just going to be a strikeout because I decided I didn't want to do that thing, let's say. So if applied, this commit will add a concept of selection. Commit. Yes, please. Thank you. Okay, so now we can do that. Work on selected task. Okay, work on selected task is going to be fairly simple. It's going to have very much the same, well, how to best handle this? Optimally, each task would be an object. Well, it would be much cleaner if we were doing this in an object-oriented way, but it's okay, because we're not going to. So we're going to make this method a little bigger than it probably ought to be. I'm going to copy something like this in. And we can clean it up at a later time. What are our options here? We need to... R is re-enter. C is complete with an L. And Q. We'll make Q cancel. So before we do that, we want to console.writeLine working on tasks at selected task. Okay. And then we will have a switch statement here that is based off of the input. Let's see. So I can get input from user here. I've got a method that does that for me. Switch key on our three options: case, console key dot R, break, case console key dot C, break, and case console key dot Q. Break. So console key dot Q is going to do nothing. It's just going to return. So it just breaks, which is fine. What best to do? What best to do? Here, we'll do this. We'll wrap this whole thing in a do loop. And we will only get out of the do loop when we get valid input from the user. Okay, we're gonna have a Boolean here. Valid equals false. We're gonna assume that all input given to the user from the user is false unless proven otherwise. We're gonna say while not valid. And then in each of these cases, we'll set valid equal to true. Okay, gorgeous. So in this case, the Q case, we only set valid equal to true, and then we return. In the complete case, we also delete the currently selected task. And in the R case, we're going to delete the currently selected task, and we're going to re-enter the currently selected task. Now, we don't currently have a method that re-enters a task. We have this method here that inputs a task to the list given input from the user, but we don't call a method to make that happen. So we should probably do that. We shouldn't manipulate the class itself in this method where we're getting input from the user. So let's see. Oh, well, there's also a bug here because if we add a task currently, it doesn't put an item into the isActioned. So that was a good thing to catch. So tasks.add is actioned, or is actioned.add, and these are always going to be false. So now I'm going to take this and I'm going to refactor it into a new method. We'll call this method add task to list. And, for the moment, I'll leave it there. That's okay. So in this case, I want to delete the currently selected task, or more specifically, I want to add the task to the list first because that's the appropriate simple scanning method. So add task to list the currently selected task. So tasks, selected task, and then delete the currently selected task. So this is our re-entering capability. And optimally speaking, I would refactor each of these out. So this would be re-enter task, and the rest of these are fine. Okay. So let's see what happens when we do that. Let's start with bookshelf. Oh, well, we don't have the ability to go up, and that's actually good. That's intended. So I'm working down through my list. I hit enter. I'm now working on the bookshelf. I can quit, in which case it's still the selected task, which is fine. That's actually a perfectly acceptable behavior. I can complete, which should just remove it from the list, and it does appear to do so. And now I'm working on the next thing, so I can work on the passenger rear window in my car, and I can say re-enter, and that completes it, and that's something I need to work on, and adds it to the end of the list. So now I've got an issue. The issue I currently have is, actually I'm going to X out of this so that these don't save. Why, thank you. The issue that I currently have, though, is that if my first item is a unactioned item, my 0th item even, is an unactioned item. Sorry, strike that. I keep using the wrong words. If my 0th item is an actioned item, there we go, then my interface doesn't work properly. And that's probably okay, because we're supposed to be dumping the unactioned items before we print them out. So I guess that'll be the next thing that I implement. So if applied, this commit will allow actioning items, and that'll be that. So now I need some sort of mechanism to remove items from the list. I'm not yet certain how best to do that. Let's think. So when should we do that? Let's start with that. We should do that every time we're in the loop before we print the task list. I think that makes most sense. So we're going to say remove first actioned items. Remove first actioned items. Love it. Okay, so we're going to remove first actioned items. And then we're going to say what's the easiest way to do this? Well, first let's see if there's an isAction.remove. So we could remove, which removes the first occurrence of a specific object from the list. I'm not sure I want to do that. We could remove all. That definitely I don't want to do. We could remove at. That removes the element at the specified index of list T. Now that's pretty close to what I want to do. It's not super optimal. Oh, I'm glad. It's a nice feature, I think. So let's see. Removes the element at the specified index, or we could remove a range, which will complicate things slightly, but not dramatically. Let's go ahead and say remove at. So we'll say while our, yeah, we'll use while. We'll say int index equals 0, while isActioned at 0, or at index, excuse me, is true. We want to, first things first, oh well, you know what, I don't even need to do this because we're only removing the first items in the list, so that's perfectly reasonable. So while isActioned 0 is, so while the first item in the list is actioned, we're going to remove that first item, and this is not the most efficient way to do this, by the way. There are much more efficient ways to change a list, particularly by not using an array-based list, because you then have to move everything at the end of the list to the beginning of the list via copy, which is really slow and obnoxious. But putting that aside, we want to remove each of the items, so we want tasks.remove at 0. We want isActioned remove at 0, and we want to subtract 1 from selected tasks, with the caveat that it needs to be greater than 0. So if we start out and we have 3 unactioned tasks at the beginning of our list for some weird reason, somebody modified the data file manually, we want to make sure that we're not selecting a negative task. So we'll check that. So selected task minus minus, or we could say minus equals 1, minus plus 1, that's a thing. And then to check if selected task is less than 0, then selected task equals 0. And yes, this is a circumstance where I could probably avoid the brackets, the curly brackets. I don't want to. I hate avoiding curly brackets. It only leads to ruin. Okay, so I think this works. Let's try it. So right now I can select through my list, perfectly acceptable. And if I delete PR window, for example, and that leaves me with one item at the beginning. So my expectation now is that if I hit delete on bookshelf, it's going to delete bookshelf, super memo, PR window, Zelda, and leave me at index 0, which will be shower. And it does appear that's correct. Okay, so I think I saw something weird there. I'm going to try it one more time. I just X'd out so that I didn't save that to the file. Okay, so that's the color I expect. Is it? It is, yes, good. So, okay, so this is working as I expect. Good. I was a bit worried there. I thought the coloration was not working quite appropriately, but it appears that it is. Okay, so now we have a new thing that we can put into a commit. If applied, this commit will remove first actioned items. Okay, so let's go back here to our center screen. Take a look at our list of requirements. We can remove our list here of tasks. So we can now delete a task. We can cancel, re-enter, or complete a task. I'll go ahead and move these up here, though they really ought not be up here because they don't really have a category to be in. Good enough. We can re-enter or cross off a task, which is part of our user controls, but is also a requirement in and of itself. The first page starts with the first unactioned task. Undo. And we can choose a task using the appropriate algorithm, where the appropriate algorithm is you start on the first page, you work down the list, and this is basically included in our algorithm already because we can't work up the list. We just don't have a command that allows us to go backward in the list to select something. It's not allowed. So I'm going to go ahead and say that for the moment, all of the requirements of simple scanning have been met. So we can now choose a task using the appropriate algorithm. And we could probably add something in there that would say, this is how you use simple scanning. But we don't really need to. Well, oh well. It's lost now forever. So here we are in the last, let's see, 22 minutes of the first 2 hours of this project, which is where I said I would hopefully be able to implement all of the basic functionality. And we only have one major functionality to go, and that's the ability to add pages. So let's add pages. Okay, so everything is committed. Let's pop back over here to Visual Studio. Everything here is committed. We're up to date. We're in a good spot. We want to add paging. So paging is going to be based off of having a page of a certain number of elements in length. And we've specified that that length is going to be 25. So I'm just going to encode that into the code, into the application using a const. So const int page length equals 25. And the next thing I'm going to do is I'm going to add enough. Interesting. Lots of interesting stuff. I'm going to add enough items here that we could have multiple pages. So at the moment we only have 7 tasks. I'm just going to cheat and copy and paste these a bunch of times. So now we have 70-something tasks. Well, I'm going to have to undo what I just did so that I don't have to manually add in the CRLFs. So copy, paste, paste. Beautiful. Okay, so that brings us to 4 pages now, because we're at item 77, line 77. We should have 4 pages now. So there are a couple of ways we could do this. First things first, let's demonstrate that it doesn't do the right thing. It doesn't do the right thing. It gives us this 75 element long list on one screen, which is bad, not what we want. So it doesn't do the right thing. There are a couple of ways to handle doing the right thing. And probably the simplest of them is just keeping track of which page you're on. And then incrementing that page as you move forward. I don't necessarily like doing that. I'd rather do this other method where we do a little bit more modulus math. We do a little bit more, it's a little more calculation heavy, I guess, but it doesn't require us to keep track of that additional page, and it allows us to continue to use our selected task as the primary arbiter, if you will, of truth. The currently selected item, the current item that we want to work on, and also the page based off of which item that is. Now, how we do that is a different problem. So let's start off with the obvious thing. We're going to start with our task being 0, and so we're going to start out with page 1. So this is all going to be done in our print task list, because that's really the only place that it matters what our specific task is. Though we will have to do a little bit of manipulation of the selected task based off of the new page option. So scrolling down here to find our print task list. So first things first, we don't want to print anymore to tasks.count. Let's start off by saying that we want to print to, well, actually we do want to care about tasks.count, but we also want to care about this new value, which is basically going to be some page number times the page length. So I is less than page length, and I is less than tasks.count. And we'll put some additional parentheses in here because it's recommended by the style guide. Okay, so now we only get the top 25 items. We don't have page numbers here or item numbers here, but we really don't need them. We're not usually going to be sharing this list with other people, so we don't ever need to say, hey, look at line 27, and have people look at line 27. Mostly we're going to be actioning this list by stepping down through the list, kind of like this, just one item at a time. Now, of course, if I reach the end, it's going to go past this first page of items. So we're not going to be on the first page anymore, and it's going to move along. We don't want that. That's the opposite of what we want, really. So let's add in some logic to determine which page we're currently on. So the page we're currently on is going to be based off of the selected task. If we're between 0 and 25, we're going to be on the first page. And if we're between 25 and 50, well, I should say if we're between 0 and 24, we'll be on the first page. 25 and 49 will be the second page, and so on. And we can calculate that fairly simply using integer division. So let's pull up a C# interactive menu here and make sure that what I'm thinking isn't totally insane. Not a guarantee. So for example, if we say 0 divided by 25, and we use integer division, that should give us 0. And 24 divided by 25 should also give us 0, because we haven't overflowed that minimum ability to reach the next point. Basically, the reason this works is it doesn't, well, it doesn't, but you can think of it as it doing a double division, or a double precision, excuse me, or a floating point precision division, and then using the floor function to truncate down to the lowest value. Is it really floor? Let's see. It's not really floor. That would mean that it's, let's see, negative 24 divided by 25. Well, that's just the truncate function, technically speaking. Floor always moves toward the downward direction, if I'm not mistaken. Suffice it to say, it does a truncating division. So we can say that the current page number, var page, equals selected task divided by page length. Being sure that both of these are integers. This is, it's an int, that's an int. So both these are ints. They're not going to be type widened to be doubles. They'll always be int. This will always do an integer division. So starting now, we can say that we're going to start on page times page length. So this will start on 0, and then on the first page, not the 0th page, but the first page, this will be 25, and on the second page it will be 50, and so forth. So we'll start our counter on the appropriate number. And let's see. Well, we're going to put this into a new variable. Our starting point equals that. Oh, I hit Control Y. That's not the right thing. So we'll start this at the starting point. And we'll say that the starting point minus the, let's see. Nope, that's it. So I is going to be less than starting point plus the page length. So basically, the place that we started counting into plus an additional 25 items, since our page length is 25. And so this should allow us to walk down our list. Hopefully, yeah, we do start in a different spot on the second page, so it does look fairly attractive. So we can continue to walk down this list and see these individual items. So now on the last page, we only have 2 items. It's important that this resets appropriately, and it does appear to do so, because we reset to 0 when we reach the end of the list. Okay, so we now have paging. It's beautiful. And what's the last thing we need to be able to do? We need to be able to go to the next page. Stop. Go away, C# Interactive. We don't like you. So we need to be able to go to the next page. In order to go to the next page, we need to be able to find the first element of the page we're not currently on. So we know what the current page is, and we can actually abstract that into a new method. So let's go ahead and do that. We'll extract a method, and we'll call this getPage. Cool. I love it when a plan works out. Sometimes IntelliSense is a good thing. And let's see. Page plus page length. So page plus page length is going to be the first element in a page. So we'll extract this one as well. We're going to call it first element in page. So the first element in page is going to be the page value that is passed in times the page length. And that actually allows us to change this one as well by saying that we want the first element in page plus 1. So this is the first element in the next page, effectively, which we can then use the refactoring tools to turn into a local variable. Sure, we can call it v, but it's really going to be called ending point. Control RR, ending point. Okay, and there you have it. So now we just have to say when a next page is asked for. Let's see. We'll just say select next page. Select next page will need to be that. In select next page, we will calculate the current page. So that will be var page equals get page. And then selected task equals first element in page. +1 because we want it to be in the next page. Pardon me. And then last but not least, we want to select the next unactioned task, which will handle for us the potential issue of having a selected task that is either past the end of the list, and we can go and check this to make sure that it does handle that appropriately, or having a selected task that is an action task, which of course wouldn't be a valid task to select, though it would be a valid task to have on, say, the second or third page. So if we go to F12, since my F12 is bound to something else. Oh, it's the next thing in the list. Oh, no, it isn't. It's a few up. Okay, so selected task plus equals 1. If selected task is greater than or equal to isAction.count, then it's equal to true. Okay, so basically all I'm checking to see here is that we don't do a dereference. We don't look at the appropriate, sorry, words are escaping me here. We don't try and look at that index in any of the arrays before checking to make sure that it's not a valid index and setting it appropriately. So this should be all we need. This should fulfill all of our requirements. We can now walk down through our list. It's a little flashy, but it's okay. Walk down through our list, removing items as appropriate. This brings us back to the beginning. Beautiful. We can delete an item, which if we have removed an item at the beginning of the list will truncate to the first actioned item. We can add an item, our great new task, which we can't see at the moment because it's at the end of the list and we're not at the end of the list. Perfectly all right. We can, of course, select the next item. We can try and action an item, which allows us to either re-enter or complete. We'll re-enter this one and we'll complete that one. Then we'll check at the end to make sure that only 2-hour task manager is after that great task that we just entered. We're going to hit quit, which we won't do. And we should be able to use the next, which apparently we can, to go to the next page. And we can see that our last 2 tasks are our great new task and 2-hour task manager. And that allows us to walk around the list 1 page at a time. You'll note that that's not true. Interesting. So we do have a bug here. The first task on this list was is unactioned, and we have selected the task after that because we asked it for the first unactioned task after the first element on the next page, which is a complicated thing to say, although it didn't require that much code. So we need to fix that. That method is called select next page. And in select next page, we basically just need to say if, now we have to do this to the check here. That's ugly. I don't like that. But I'm afraid it has to be done. What's our alternative? Let me check what we're doing in first element in page, because it's possible. Well, no. So we've got 2 options here. First element in page currently just gives us the, well, yeah, this is appropriate. First element in page gives us the theoretical first element of your next page. However, if there were no next page, this is going to give us an index that is past the end of the array. Select next method is handling it. The problem is that we need to check to ensure that when we call select next, that we're not calling we've got a pathological situation. That's what it comes down to. So in the normal case, when we call select next, it's because we're on an actioned task and we want to be on the next actioned task. And you can think of that, for example, if we have just loaded the list, we're on the 0th element of the first page or the 0th page, and we want to select the next thing. This isn't that situation. When we choose next list, we are moving to the 0th element of the next page, which might be an unactioned task. And if that is an unactioned task, we don't want to skip that task, because otherwise we'd have to go around the list all over again and then go down to the end of the page before to get to that 0th element on the next page, which is silly. That's breaking the law of least astonishment for our users, which we don't want. So we really need to add an additional check somewhere that keeps track of whether we need to ask for the next selected item. And unfortunately, I think the best place for that is going to be in this, not get input from user, but the select, well, which one is it? Shoot, I've lost it. Select next page. I thought about adding it to the select next unactioned method. The problem there is that how does the select next unactioned know the difference between the actioned task that you're currently on and the action task that you were on, or the action task that you're on legitimately, or the action task that you're not on legitimately? We could add an additional, for example, an overload that says if you're already on an unactioned task, then don't move. That would be possible. We could also... You know, the appropriate thing to do might be to subtract 1. Let's try that. So if instead of saying first element in page, page plus 1, we said first element in page, page plus 1 minus 1, which gives us the last element on the previous page. It's a little hacky, a little bit. I'm waving my hands here. It's a little hacky, but it's not too bad. Certainly cleaner than doing a check to make sure that the currently selected task is a valid index, and then only doing select next unaction task if it isn't a valid index. Let's try that. Let's see what happens. Well, now this works properly. That works properly. This works properly. Yeah, I'd say that's the correct answer. As silly as it seems just looking at it, I'd say that's the correct answer. And so now I'm going to open the floor. Have I missed anything? Is there any requirement? I'll pull up the requirements here in the center pane. That's Alt F2 and transition there. Is there anything that I have missed? Let me go back to my original list of... Oh, no. Gone too far. Okay, is there anything I've missed? Because I think that we've reached the point where I've done this this first basic set of requirements, the, if you will, minimum viable product within the time allotted, and it seems like everything's working. What do you think? And while you think, I'll go ahead and make the final commit on this. Hopefully it is the final commit on this. Beautiful. I think so too. So I will go ahead and create a nice little GitHub page for this and push it on up for review. I will make the video available somewhere. Haven't quite decided where to make that available yet, and I will share it in the Discord. And that'll be that. I think that's all for me. Thanks for joining me, guys. Gals, if you're there.